Okay, so
Whose
we
hair
are
is that?
very excited to have Todd once again with us.
Oh, thank you.
And yeah, take it away, Todd.
Cool. So, this is something I'm quite passionate about, Angular architecture. So we're not going to kind of go into deep code examples, etc., etc. But what I want to talk about is just high-level design. How can we think better in terms of architecture? So I've called this From Patterns to Implementation. So we're going to look at a completely non-programming example of something, and then try and think about how we can apply that to our Angular applications. If you do have any questions, probably look at the other screen because that cuts my name out. But you can find me on Twitter afterwards, anytime, shoot me a tweet. Happy to try and answer some questions. So the objective of this talk is to discuss some concepts and patterns, and I'm going to use the word system. So you may be thinking, okay, when you build an application, we have a component system, we have some state management systems. So these are the kind of things that we're going to look at. We're also going to try and discover some different thinking for our code. And this is something that I've been trying to do for myself, like the last couple of, probably since January this year. Maybe December. So, and the question that I'm trying to answer is, what can we learn from non-programming systems? So when you go back to the office or back home and start working again, so instead of just writing some code and rinse and repeat, sort of try and think a bit higher up. How can we approach this differently? So we're going to look at systems. Systems is kind of like the first half of this talk, and then how we can apply it. So first off, what is a system? A set of things working together as parts of a mechanism or an interconnecting network or a complex whole. So I kind of think of a system, if you think of like maybe a train or an engine, all these complex parts that are individually working and they come together to form something more complex. There's another quote on what is a system. It's a set of principles or procedures according to which something is done, an organized scheme or a method, which you can kind of think, as we continue through this, how you can think about your code in terms of this, Angular modules, components, all these types of things. So why are systems important? Why should we bother even thinking about them? So each part of a system has a specific responsibility, and they have a separation of concerns. Like if you take an engine, for example, you've got the pistons inside, which go up and down, ignite the fuel. That doesn't play with another part of the engine. They are completely separate. And our code should kind of follow the same pattern, separate of concerns. Also makes things predictable. If the engine broke down, for example, we could replace something very quickly. I'm sure we've all got hit by some expensive car bills at once upon a time. And also consistency. So when we're building in a bigger team or a bigger application, we want to follow a process. So we're going to have a look at a completely different perspective on architecture using a restaurant as an example, because we've all been to a restaurant, and we can use this dotted green thing to imagine your favorite restaurant, a pizza restaurant, whatever, favorite food. So we're going to keep it simple. We won't go into tables and chairs and decoration, logos. We're going to think about the two building blocks of a restaurant. We've got the staff of a restaurant, so the waiters, the chefs, all of the managers, these types of things. And then we've also got the stock. So the stock in terms of like food and drinks. So we need two separate things. The staff, they can look after the stock. When a customer comes to order something, they can order off of a menu, and that menu is driven by the stock. So we're going to use these examples to kind of just think about a different system and then how we can tie it back to our application. So what is the responsibility of a staff member? So some staff members, they will deal with customers. They will also deal with other staff members. It's good to have communication. And they also follow a same process. Each staff member might have a specific responsibility. Could be a kitchen staff who's responsible for this at the end of the day, or that at the end of the day. You could have someone who follows the shipping processes, the orders, these types of things. And then presenting stock choices via a menu. So here's what you can eat today. What would you like? Goes off to somebody else. And then in terms of stock, now the stock defines essentially what the customer is going to request. If you've got pizza, they're going to request a pizza. If you've got a burger, it's going to request a burger. Now the stock doesn't just arrive in a particular restaurant, we have to order that in. So the stock is managed by the staff, but it's who manages that restaurant stock. And the stock, it's got to be well organized, it's got to be fast, it's got to be efficient. You don't want to walk into a big chef's fridge and just food. Has anyone watched Gordon Ramsay? Yeah, think about that. So he's very good at that kind of thing. And this was kind of inspired this talk. Messy fridges are not going to make happy customers. Now, the interesting piece is that the stock comes from third-party suppliers. So we can apply all of these things to our applications. So we'll work out how to tie these in. So if you try and think as we go along how we can apply this to our applications. So a restaurant probably encapsulates the staff, it encapsulates the stock, and you can kind of think of these as modules, like an Angular module. Staff could be the components, and the stock could be state management, for example. So what this is, try and think as I go through these, how we can apply them to that kind of thinking. So the restaurant also manages the supplier contacts. You might say we have a drinks vendor, food vendor, and they're different contacts. Then we've got things like decoration, tables and chairs, and all of this you can think you've got all your services, directives, pipes, they all get bundled. So the restaurant is kind of a module if you think about it. And the most important thing is customers want to go there. So I mean, at the end of the day, if we're building terrible apps, nobody's want to eat at our restaurant. So let's talk about the staff roles. So a manager, and try and think about these in a component fashion. So a manager is responsible for a stock. What you do not want is an employee running out of ice cream and ringing up and ordering $10,000 worth of ice cream, which sends the restaurant bankrupt or something. The manager is also responsible for ordering new stock. So he will have, or he or she will have, the contacts with the supplier, and they say we need some new ice cream or some new pizzas. And then once the new stock has arrived, he can then say, okay, staff, kitchen staff, we've got all this new food, we need to put it away in the fridge or the freezers. So let's have a look at the waiters / kitchen staff. So they're not in charge of ordering the stock. You might have an assistant manager somewhere that kind of is, but the principle is the manager is in charge of dealing with the stock, and he simply communicates that down to the other staff. So when the kitchen staff needs new stock, he might say, oh, we've run out of burgers, we've run out of pizzas. They will then go and inform the manager. So this is a clear representation of roles. And once the stock has been delivered, the manager then gives them information. So there's a process here of flow of what's happening. So you may have seen something like this in a component architecture diagram. So what I've kind of got at the top is the supplier. And try and think of these as a bigger system than just components. So the supplier, we don't just ask for something and it immediately gets given to us. There's a whole ecosystem that dealing with the supplier that's going to happen. Now the management staff, they deal directly with the supplier, and the supplier deals directly with the management staff. But you can see I've got this gray dotted box. This is kind of the next level of staff. And you can kind of think how this applies to things like state management and component architecture. There's no waiters down here, or you might have a bigger tree where somebody's dealing directly with the top level. And there's good reasons for all these. So this ends up with clear communication. We don't want a team running around, nobody knows what's happening. And it's easily extendable. If we have more staff members, they'll just slot in somewhere, follow the same process. And everyone has a defined role and a process inside of that. So the kind of summing up is these are moving parts that work well together. They're small, isolated pieces of, like an engine, that all fits together to form one thing. So that's the kind of overview on the staff side of things. So let's have a look at the stock. How do we kind of think about the stock management? We'll be tying all these things together after a couple more slides. So let's assume we've run out of stock. We need some more pizzas or burgers. The manager is then going to initiate a supplier request. He's going to say, okay, I need to go and tell XYZ company that we need something. So what happens is he alerts the supplier. We say, we need this stock. And you can kind of think of this as like a payload that you're sending out. The supplier then confirms the receipt. The supplier then fulfills the stock order. Then the supplier sends the stock order back. And the manager, coincidentally, gets notified when the delivery arrives. So there's this whole one-way system that's kind of happening outside. And if you think about it, we haven't even mentioned any other staff members. So For me, this is your state management, and the staff members are thinking of components, and these are completely two separate topics. Quite like that little. So here's kind of the flow. So the manager in the purple, he sends a request, and you can treat this green dotted line as the supplier. It doesn't matter what it is. It could be ice cream, pizzas. So what he sends a request for the orders. He says, this is what we need for our stock update. The supplier will then receive it. They say, okay, we're going to process this information now. We're going to go and get our supplies. And then they're going to package it, and they're going to essentially pass it back as some new stock, drive it all the way to the restaurant, and then everything gets delivered. So this comes back to the manager, and then he can then go and inform his staff that the stock has now arrived. So this is kind of how I kind of think with data flow. It's a completely separate topic, and this kind of gives you a better example than just, oh, why should we use Redux or NGRX, these kind of things. So again, this management, or this stock management architecture diagram has those benefits that we had with the staff. We have clear communication, it's easily extendable. We could have two managers, let's say. They could all just deal with the same supplier, and we know the process, it's simple. Everyone has a defined role. The supplier doesn't try and communicate with kitchen staff, and the kitchen staff don't communicate with the supplier, but they both have a unique contact. So they have well-defined roles, and again, it's moving parts that work well together. So if you think about all those things in terms of your application, there's a lot of things happening, but we want to divide them up. And the reason that we would want to divide them up is in a small application or a small restaurant, it's kind of simple. But let's assume that we start having a busier restaurant, and we all of a sudden, we need more staff, we need more stock. Who's going to manage it? We might have 4 different managers. So when we kind of separate these entities and try and treat them as different things, they kind of scale well. And they scale even better. Like, let's assume that this restaurant is even more successful, and they decide to open a few more stores. Like, you can try and think of how you can expand and scale your application by following a process and a procedure. So let's have a look at some of the Angular side of things. I know that's what we're all here for, I think. So some of the observations from just thinking about something completely irrelevant to coding. They've got a scalable model. There's clear steps of what happens. The staff look after a particular role. The managers have a particular role, and they communicate with both a supplier and other staff members. There's no surprises. You don't all of a sudden get a kitchen staff ordering 10 gallons of ice cream that wasn't meant to be there. There's no process issues. We get the separation of concerns. So if, for instance, you want to scale the kitchen staff, that's easily doable. You don't have to train them all how to deal with suppliers and these types of things. So it's creating lines and division lines. We can also have define the solid processes for architecture. It's simple if you have like a team and you say, this is how we do things for state, this is how we think in components, rather than just throw everything together and hope for the best. So this is maintainable, it's efficient, it's predictable. We can write tests against this. We could review a kitchen member's staff. We could replace them out. So it makes things simple. Growth is easy as well. So that was with a system, what we kind of get thinking about it. So this is what kind of would happen without a system if we didn't sort of treat these as two separate things. So first off, who would order stock? Like, how do you have that conversation with perhaps 100 employees? Who's responsible? Somebody might be ill, or somebody might not know how to do it. So I've put commence the chaos. If all of the staff are trying to order all these different pieces of food and things, you can imagine how it's going to affect the customers that actually want to use the restaurant. Money's going to be spent, money's going to be wasted, time will be lost. It also presents a challenge to scale, and because we're talking about restaurants, I put a really bad spaghetti joke in there. And it's not a flexible approach. We don't kind of get that flexibility with, okay, we want to scale the kitchen staff. We can't really do that very easily. And there's tightly coupled processes. So putting it all together, this is like the full diagram. So here in the gray, we have the manager, sends a request to the supplier, receives it, blah, 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 packages it, comes back to the manager, perfect. So at this point, the manager can say, okay, team, staff members, kitchen staff, waiters, we've got a huge delivery, let's go and carry on. So all this part over here, which is happening, is completely separate to the other process. And it doesn't matter how you kind of do this in terms of state management, whether you use a library or a different architecture model, a state management model. But that clear division, as you can probably kind of guess, is just using a different example like a restaurant, starts to make you think a bit clearer. And when we then flick things over, and I'll just toggle between these, we can think about these in terms of Angular. So a container component, we talk about containers, stateful components. They're in charge of getting data. The components shouldn't really care about it. So they're in charge. They can dispatch an action like we do in NGRX. They get sent to a reducer where we can compose things, and then we return the new state, and it gets bound back to the container, who can then tell his staff, here's the new data that we have available. So creating this kind of structure and this separation is really beneficial. And here's kind of the main things that I like to think about, the 3 topics in an Angular application for trying to think of different systems that are working together. So we have modules. We do things like lazy loading, eagerly loading. We've got root modules, shared modules. So that's kind of a system on its own. We should think about those differently. And similarly with a restaurant idea, each restaurant might be the same brand, the name, but they might be run slightly differently. With components, we could think in containers and presentational components. And then we accept things like inputs and outputs, the standard things. But it all comes back to that one-way data flow. And the state management has that one-way data flow as well. So the things that I'm kind of interested in with state are, 1, the state tree. We keep that completely out of the component, and we've kind of demonstrated that supplier diagram, which is kind of our state tree or the state process. So we completely abstract that. With our reducers, for example, we can use entities. Like you probably, when a manager orders some new stock, he probably doesn't say, here's the full label of, I want Wool's ice cream 6 liter. He probably gives them just a 6-digit code or something like this that the supplier will then look up. And in NGRX, we call this like an entity. You can use just a flattened data structure. And we typically do these via the unique IDs on the data structures. With selectors in state management, we can compose that state. And this was kind of an interesting thing for me, is instead of just diving and going, okay, what do we need to create in our component tree? It's, okay, what data can I provide first? So I'm thinking state first, and then you can compose the data, and your components simply just consume it. They don't create the state. They just consume the state. And the router is also really important as well, because we're dealing with client side. We can bind everything using the router store module to our state tree. So everything is just accessible in a single place. So let's have a look at some component architecture stuff. So this is what we looked at before. We had the manager who's responsible for the stock. The other staff are completely not. So when we talk about components, we have a container which is aware of the store, but our presentational components are not aware of the store. They shouldn't even know it exists. We should be relying on one-way data flow and think about our presentational components as small little functions that can just be reused. So the container can dispatch an action. That's how we kind of get information out of a container component, and then we can continue that whole system diagram. And if we want to get data out of a presentational component, we want to simply invoke a callback. We use the event emitter via an output. If we want some data in a container, we can ask for it via the store, and we can also read the data from the inputs with a presentational. So I've also got a diagram which kind of explains these a little bit more visually, because I think these help nicely. So we've got the store, containers, and it just passes things down. And this is the completely unaware zone. We don't care about the store at this point. Components don't really, they don't care how they get their data as long as we have some data. So when we want data in a component, we can use the select method just as an example for something like NGRX. So that's how we get data in. And everything else, you want data in every other component, we just use an input. If we want it out, we use the output. And in a container, we just use a dispatch. So you can kind of think as select is just an input for a container, and dispatch is an output for a container. It's the same kind of ideas and principles as the at input and the outputs. So thinking about state management, this is what we looked at with the stock management when a manager kind of goes through these things. So the manager initiates the supplier request. They confirm the receipt, they fulfill the order and send it back, and the manager gets notified. So this is kind of the benefits of thinking of this approach in an Angular app. So the whole process with state management is we should kind of communicate outside of the component architecture. So component architecture is one system, state management is another system, and we've got that small module system which we can also think about. So we can dispatch actions for intent. That's how we kind of get things out of the component architecture. We can use immutable operations. These are beneficial with like on-push change detection. And the way that we can then give data to the components is using like a selector in like create selector with NGRX. And it's simply creating like data tables of your state and just simply selecting pieces you need rather than trying to create a reflection of the state you need down in a component tree, which I think this approach is far easier. We can focus on immutability. That comes pretty much for free with things like reducers. And the other thing is reducers, selectors, they're pure functions. They're so easy to test. They're pretty scalable, they're pretty fast as well. So we can also think about this as like how do we scale a restaurant, for example. So here's the final kind of diagram on state management. We have a component which dispatches an action, it comes back to the reducer. We get that new state, and then we can continue the journey. And this is the kind of final state management kind of diagram, high level, the system. So here's some closing thoughts, and you don't have to adopt things like NGRX, etc. So state management, it doesn't kind of matter so much how you do it, but things need to be fast. They need to be scalable, maintainable, testable, hopefully, because we all like writing tests. So we can think about this as a separate thing. So we've got state management, component architecture, and those, for me, are two separate things. When we manage them individually, there's a better way to manage state than just purely inside of a component. Or like services, for example, they also have their own pros and cons, like lazy loading, etc. So we can abstract your logic, consider something like the Redux pattern, which, as we know, our friends in the React community created for us, and we just stole it and made it observables driven. So component trees, and I've mentioned this before, like component trees aren't for, okay, I need to create an upload component, how can we make it cool? It's, okay, the upload component, as an example, would be the result of your data structure and the state management, and you only compose the components as a result of and what you need to consume from the state. So I try and create all the state stuff first and then build the components, rather than build the components, build the state, and then think, oh, I've done this the wrong way in pieces. So it kind of creates a clear division for me. Abstracted state is easier to compose, it's easier to share. If we've used different selectors, and I mentioned things like the router state, we can bind that to a single source of truth, the state tree. That's easy to use across any kind of module, lazy loaded module, it doesn't matter. Whereas when you're dealing with perhaps 10 data services and you've got crazy observables everywhere, those do get a bit difficult to kind of manage. They're easy to reuse, so we can create selectors, which are just pure functions which can return something further down in the state tree. And also I've mentioned that they're super easy to test. So that's pretty much it from me. It's kind of what I want you to kind of go back and think about is, okay, I don't want to just dive down into the code. How is this a system? How is my component architecture system? How does it look? And you could even grab a notepad and just draw some boxes and some circles and try and evaluate where you've got lines which are crossing so we can start to think about separation. I've also recently released, this Monday, I stayed up for about 3 months without sleeping. So I recently, if you want to learn more about NGRX on ultimateangular.com, I've pushed out a free course, which is about 7 hours long. So that'll teach you like the whole crazy side of Angular. And then this is a state management kind of module where we can then bring into that component system, and we've got the whole thing which clicks together, and we've got a successful restaurant at the end of it, which customers want to use. So thank you for listening. I hope that was kind of good to take a step back from the code and just think a bit higher up. So thank you very much.
Thanks, Todd.